A rational function can have vertical asymptotes only at the points at which it is not defined. So we look for asymptotes among values x excluded from the domain. Since we can exclude more than one value of x from the domain, this leads us to the statement that a rational function might have more than one vertical asymptote. If I have a function given by a formula, like in our example, how do I find the vertical asymptote for this function? We'll follow the steps 1 through 3 on the left to accomplish the task. The first step is to reduce function to the lowest terms. So that means factor numerator and the denominator completely and cancel common factors. So the numerator is already factored, the denominator factors is x minus 1 times x plus 1. The common factor in numerator and the denominator is x plus 1. We can cancel it out or divide by x plus 1, and we obtain reduced form 1 over x minus 1. Just we have to remember that this simplification, that cancellation, can be done only when x is different than -1, assuming that x plus 1 is not 0. Obviously, in the formula of the function f, we cannot use also x equal 1. The second step is to solve the equation denominator of the reduced function equals 0. So this, in this case, is going to be x minus 1 equals 0, which gives me quickly solution x equals 1. And that solution in step 2, or solutions if we have the larger equation, result in the vertical asymptote. Since x equal 1 was the solution, this is the point excluded from the domain, a vertical line with the equation x equal 1 is also the vertical asymptote. Notice that we excluded from the domain of the function also x equal -1, but this line x equal -1 is not a vertical asymptote, simply because when x is close to -1, so x plus 1 is not 0, the value of the function f of x can be computed using that formula. And if x is close to -1, the values of 1 over x minus 1 will be close to -1/2, and therefore it will not result in values that are large, either positive or negative, and therefore there is no asymptote at x equal -1.